Uh, Hello, my name is Sean Kelly, and I'm presenting my science fair project, which is the effect of different pollutants on freshwater diatom growth and populations. This project is a continuation of what I did last year. Last year, I did a similar thing. I incorporated pollutants as well, but I just tested to see what the pollutants effect is on diatom growth just in flat, not different pollutants. What I did last year was I separated two populations, one in Beargrass Creek, an infamously dirty and polluted creek waterway, and I put another set outside in a controlled, stable environment. And data from that study was inconclusive, and nothing was really proved from that. So, and also it wasn't all that complete, and it was kind of janky on the other side. So what I did this year is I was trying to be more specific about what pollutants were in there. So, to introduce the type of diatoms studied in both last year's and the current year's studies are freshwater, due to the fact that that's the only, that's the relevant in this part of the world. And so, as for an introduction to diatoms itself, diatoms are very small photosynthetic organisms that live in brackish, clear, fresh, and salt water. They attach themselves to surfaces and live off sunlight, and are a basic fundamental part of the ecosystem due to the fact that they're producers, and they help give the one-up predators, level 1 predators, the food they need to survive and control populations. So they are important to life ecosystems in rivers, lakes, oceans, swamps, whatever. And based off previous research, there is significant evidence that pollution does affect this, but there isn't all that specificity. So, my hypothesis going into this was, okay, so the thing that's going to block photosynthesis is what's going to inhibit growth the most, which I thought would be plastics. I thought plastics, cans, things of that nature would be the most prohibitive because of their nature to block sunlight and being minimally translucent. I thought the dirt and the ground sediment would do something. I didn't think it was going to be, or I thought that it was going to play a factor, but not a major role. So, to test, I set up isolated environment. I took water from Beargrass Creek and isolated 3 buckets of environment. And these buckets were placed in a room which was free of animal interference and of human interference. The room was consistently lit. The room had a consistent temperature. The room was not entered, nor was it touched during the process of this experiment. To measure these environments based on their diatom population capacity, one was put with minimal dirt and a small layer of rocks at the bottom. One of them was filled with dirt and a copious amount of sediment, which was not stirred around, but stirred around naturally. And then the third one had dirt and plastic incorporated. It had a plastic semi-translucent piece of debris floating on top of it with the same dirt quantity as the second environment. To test diatom populations, microscope slides were hot glued to a styrofoam rectangle that had a string through the middle of it. That string was then tied to a rock, which was sunk to the bottom of the buckets. These floaters would sit in equal amount from the surface on in each environment. They were left to sit for 4 days without any interference, and then the rope was cut, and the floaters were taken out, and the microscopes were taken off the floaters and examined under a microscope. The first group, which was with the rocks, which was mostly clear, had the most diatom populations, the highest average, the highest total, and the highest maximum, with a great standard deviation as well, a very, very large one. The dirt one, the dirt one without any plastic, fell off a cliff compared to the clear one, with much lower averages and maximums and totals. The dirt plastic environment was noticeably and statistically significantly lowered than the dirt environment, but it was not nearly as severe as going from the mostly clear to the dirt environment. With the dirt environment having the second highest standard deviation, but not nearly as high as the mostly clear population, and dirty plastic having the smallest. Dirty plastic and dirt had similar standard deviations. To wrap up the conclusion of this, the hypothesis I had was it was supported and not at the same time. I thought plastic would have the most effect, but clearly it was the dirt. Clearly dirt had a steep, and even though the standard deviation for the clear population was so high, the difference between the average of clear and dirt is so large that it doesn't really matter how big that is. But the dirt with the plastic is significant statistically with standard deviation, but it's much smaller deviation. So I was wrong in which one would fall off a cliff, but I was right when it fell off a cliff. So I'd infer that the way it is because the dirt probably blocked more light because it was stirring around, but after a while it did settle to the bottom. But the plastic was translucent. Even though it had some dirt in it, it wasn't totally filled. So I guess that's the way it happened. And further research, I guess, would be to isolate clear dirt, plastic with no dirt, and then with plastic and dirt together to see specifically how plastic equates into this. Because I think the dirt in the plastic might have played a bigger role, but I can't tell because of what I did. And that wraps it up.